Our lesson today is adding four-digit numbers. Our I can today is I can add four-digit numbers with regrouping. And I'll know I'm successful today when I can use at least one regrouping strategy to add four-digit numbers. First, let me go over what regrouping means. Regrouping is whenever I'm going to rearrange my groups in place value to carry out an operation. So for example, in the problem 22 plus 56 equals 78, we don't have to regroup. When I look at the ones place, 2 plus 6 equals 8. So it does not go over 10. So that means I do not have to do any regrouping. But for the problem 37 plus 48, let's take a look at the ones place. We have 7 and 8. So 7 plus 8, the answer will be more than 10. So since that's a two-digit number, we need to regroup by giving my tens place in the answer, 15. The tens place will then have to go above the other tens place. So that's what regrouping is. Just like in previous lessons, we are going to be using this word, the word reasonable. And just remember that means when answers are close to each other and make sense. This is a new one for today, commutative property of addition. That is going to be a property that you are going to see today when we do one of our problems and later today when you are doing your math book. So the commutative property of addition says when the addends are the same but are in a different order. And you will have the same sum in both problems. So you'll see later today what I mean by that. When the addends, so the numbers in the addition problem are the same, but they're just flipped around. They're in a different order. But we should get the same answer or the same sum. This is my hint in remembering the commutative property of addition. Flip-flop. In the problem 3 plus 7 equals 10, let's see what the commutative property would look like. So let's do our hint, flip-flop, and 3 plus 7 equals 10 is the same as doing 7 plus 3 equals 10. So my 3 and my 7s are flipped around, they're flip-flopped, but our sum of 10 is the same. So it does not ever matter when you are adding what position your addends are in. If the number is first or if it's second, you will always get the same answer or the same sum. All right, it's time for me to show you some regrouping strategies. Let's look at the problem 5,964 plus 375. I'm going to take a look at my ones place, and I always solve what's in my ones place first. So we have 4 plus 5. That gives us 9. So no regrouping there because 9 is less than 10, right? It's a one-digit number. And then we have 6 plus 7. That is 13. So that's more than 10. We have a two-digit number, right? More than 10. So we put our 3 down under our problem, and our tens place, that 10 from the 13, goes above our hundreds place. We have to carry it and regroup it over to the next place value. Then we have 9 plus 3 plus 1 from that last problem. And we have 13 for that. And last, we have to go now over to the thousands place for solving our last bit of problems. So we have our 1 plus 5. Remember that 1 is really our 10 from the 13 from the last answer. And we have 1 plus 5. That gives us 6. So our final answer is 6,339. The next part of this strategy is checking to see if it's reasonable. Well, whenever something is reasonable, that's kind of my hint that now I need to estimate. And I need to make sure when I estimate that I solved my last problem with the exact answer, that I solved that correctly. So when I estimate, that's kind of like checking my answer by doing the problem a different way. So I have a choice. When I estimate, I could either round to the nearest 10 or the nearest 100. I'm going to round to the nearest 100. So that's going to look like the problem that's to the right. So I drew arrows right by my first addend, so you can see that number rounded to the nearest 100, and then an arrow by the second addend, so you can see that number rounded to the nearest 100. So I have 5,964. So we talked about estimating and rounding before. So I know that when I'm rounding to the nearest 100, I have to look at my tens place. So in the number 5,964, I have a 6. Remember my little tip from before. If the tens place is 5 or higher, I need to round up. 6 is higher than 5, so right, 5 or higher, so I'm going to round up. Well, the next 100, 9, if I went up, it would be 10. So that's actually going to make my number a new 1,000 number. So in this case, it's going to be 6,000. When I look at the number 375, again, we are going to look at the tens place when I round to the nearest 100. Tens place is a 7. 7, is that 5 or higher? Yes, it is. So I'm going to round up. And when I round up, I go up to the next 100, right? 300 turns into 400. So our new estimated problem is 6,000 plus 400. And that gives us the answer of 6,400. Now I need to look at both of my answers. Remember, our first sum we came up with was 6,339. Is that close to our estimate of 6,400? Are they close to each other? Yes, they are close. So yes, these answers are reasonable. They are within less than 100 of each other, so I would say those are very close. For the next problem, we have another word that we need to go over. You might see this word a lot. Unknown. So anytime it says find the unknown, it kind of sounds like a scary word, huh? Unknown. Well, it's not. It's just the answer. It's the sum. So in this case, because we're adding. So anytime it says find the unknown, it just wants us to find the answer. So we have two unknowns right here, but I'm noticing that these two problems have the same numbers in them. Aren't they just flipped around in a different order? Remember, that was the commutative property of addition. So let's test this out with our 4-digit numbers as a strategy that you can use for regrouping. So I have the problem 3,656 plus 2,871. The problem on the right is the same problem, but the 2,871 is on top. And then the larger number was on the bottom. Remember, the commutative property says they should have the same answer. So let's test it out. I am going to do our problem on the left first. Okay, so with the 3,656 on top. Let's look at our ones place. We have 6 plus 1. That gives us 7. 5 plus 7, 12. So remember, since 12 is a two-digit number, we need to do our regrouping and have the 2 be on the bottom and then regroup our tens place over to the next place value. After that, we need to look at our hundreds. And we have 1 plus 6 plus 8. And that will give us 15. So again, we have a two-digit number, so we have to regroup our tens over to the next place value. And we have 1 plus 3 plus 2, and that gets us 6. So our sum, or our unknown this time, is 6,527. So we should get that same answer for the other problem, but let's just double check. So instead of 6 plus 1, now we have 1 plus 6. Oh, we know that that's still 7, so we'll put our 7 down. Then we have 7 plus 5. Remember, that was 12, so we're going to put our 2 down, and we're going to carry our 1 from our tens place over to the next place value. We have 1 plus 8 plus 6. That gets us 15. So our 5 goes down, and our 1 from our tens goes up over to the next place value. We have 1 plus 2 plus 3, and that gets us 6. So we have 6,527. Oh my goodness, that is the same answer. So that proves to you that the commutative property of addition always works. No matter what order those addends are in, we get the same sum. So remember, our goal today was I can add four-digit numbers with regrouping. I'll know I'm successful today when I can use at least one regrouping strategy to add four-digit numbers. So I taught you at least two strategies today that you now can look back at if you need to look back at them again. And remember, your goal today is just to use at least one of those today. And in your math book, you will be able to accomplish that goal.